A director needs hundreds of period-accurate costumes, specialized set construction, municipal permits, and an army of crew members just to set up the lighting. For independent creators and educators without millions of dollars, the alternative is usually much quieter. We see it constantly in documentaries, a slow, static camera panning over old archival photographs. But over the past few years, generative AI models like Luma's Dream Machine have started operating as desktop visual effects houses. From a simple text prompt, these engines can calculate lighting, texture, and motion, outputting photorealistic 5-second historical clips. There is, however, a catch. When you type a simple historical wish into the prompt box, the system has to guess the details. The result is usually a hallucination. A boat might morph into a modern vehicle, and a face will warp into something entirely different by the end of the clip. You cannot treat these engines like a slot machine and expect cinematic history. Usable footage requires abandoning conversational prompts for the strict technical workflow of a professional film crew. The core engineering challenge in generative video is called AI drift. Because the model recalculates the image every single frame, a historical figure's face, clothing, and environment will wander and change without strict boundaries. To lock down boundaries, we start in pre-production with a master reference asset. Feeding the AI orthographic views, front, rear, side, and T-pose, defines their exact geometric parameters. We then extract a structured text blueprint, creating a checklist that locks in specific variables. This text blueprint acts as our singular source of truth. Before the AI renders a single new frame of video, it is forced to anchor its calculations back to this exact description. By mathematically defining exactly what cannot change about our subject, we free the AI's processing power to accurately generate the variables that should change, like the environment and the shadows. This brings us to production, where we dictate how those shadows fall. This visual formula maps out the strict linguistic schema the AI uses to interpret visual commands. Camera type, plus the main subject, their action, the camera movement, lighting, and finally, mood. A casual user might write, a historical figure riding a horse in a storm. The AI has no direction, so it guesses the composition, resulting in a flat, uninspired shot. But watch what happens when we map that exact same scenario to the camera syntax. We specify a dynamic wide-angle tracking shot, capturing 3 characters on horseback, and command a crane-up motion under harsh, diffused lighting. The engine processes these specific variables and outputs deliberate professional framing. The lighting is physically accurate to a storm, and the camera tracks smoothly. Speaking the precise vocabulary of a cinematographer stops the AI from making randomized guesses. You are no longer asking it for a picture, you are giving it a shot list. There is one final hurdle. Even with locked characters and precise camera angles, if you let the AI run too long, it invents too much random motion, and the physics of the scene begin to unravel. To control the physics, we use a keyframe protocol. Looking at this timeline diagram, we upload a specific start frame and an end frame. Instead of the AI wandering chaotically, it snaps into a single deliberate trajectory between these 2 points. These keyframes act as temporal anchors. They force E-Engine to logically calculate the physics of the in-between frames. The start and end points are fixed, creating rigid guardrails against hallucination. In post-production, we render these constrained 5-second blocks one by one. Then we simply pull them into a standard editing timeline and stitch them together. Bounding the AI's timeline mathematically is the final step. It takes isolated, unpredictable bursts of generation and transforms them into a continuous, controlled cinematic sequence. When you combine anchored characters, directed camera syntax, and keyframed motion, the result is a unified historical sequence. The scene holds its structure, evolving seamlessly from a wide establishing shot down to the specific details of a character's face, and the economics of what we are whipping at are 0. There were no location scouts, no municipal permits, and no physical cameras required to capture this light. True synthetic media requires moving past the idea of passively generating content. It is about actively directing data models with intent and precision. For independent educators, documentarians, and historians, this represents a massive expansion of capability. You can now execute these epic, sweeping architectural shots of ancient monuments mid-construction, entirely without leaving your desk. The visual processing power of a major Hollywood studio has been condensed into a software interface. The ability to recreate history belongs to anyone willing to master the syntax of the machine.
We are going to completely transform the way you think about audio by turning those simple little browser tabs on your computer into full-fledged music production studios. We're looking at Suno and Udio, and we aren't just treating them as basic AI generators. We are treating them as your very own personal AI music departments. I mean, think about that for a second. Really hook yourself into this idea. Imagine having an absolutely unlimited music budget directly at your fingertips. Let's say you're directing a scene, right? And you suddenly decide you need a sweeping 60-piece cinematic orchestra to build tension. Or maybe you're cutting a cyberpunk sequence and you need a gritty industrial sound design studio to create a pounding background track just by describing the vibe of your script. What would you create if those barriers were literally just gone? Now, if you're a bit skeptical about the quality, hey, I completely get it. But consider this really authentic reaction from a veteran traditional film composer sharing their experience on Reddit. They literally said, "I've been a composer for over 30 years. It's the first time I felt emotionally impacted by a piece of AI-generated music." I mean, wow. That completely validates the power of these platforms. We are way past the gimmick phase, guys. These are serious tools capable of profound emotional resonance. So, to get you operating at that professional level, here is our playbook for today. We'll start with your AI music department, move into the Suno versus Udio philosophies, explore the art of prompting, figure out extracting stems and MIDI, and finally wrap up with commercial rights and ownership. All right, let's jump straight into section 1, your AI music department, and hiring your new browser-based composers. Which takes us right into section 2, Suno versus Udio philosophies. It's the ultimate face-off between structure and fluidity. Consider this, your orientation as the director of these incredibly powerful new AI specialists. Because you're no longer just a creator, you're an executive producer now. And it is absolutely crucial to understand that Suno and Udio aren't just identical competitors. They're tools built on totally different foundational logic. Let's break it down. Suno is highly structured. It thinks in terms of spec sheets and tags. It actually have a built-in V5 digital audio workstation, or DAW, and it is incredibly reliable for nailing vocals and broad genres super quickly. Udio, on the other hand, is fluid. It prefers natural language. It boasts really deep timeline editing capabilities and is widely considered exceptional for instrumental, orchestral, and cinematic textures. Basically, Suno executes instructions while Udio interprets your creative intent. Knowing which one to pull off the shelf is half the battle. Speaking of deep editing, Udio's fluid nature brings us to this massive feature, Inpainting. Basically, Inpainting allows you to highlight a highly specific section of a generated track and regenerate just that part, while keeping the rest of the song completely untouched. Why does this matter? Well, before this, if you generated a track with an absolutely flawless verse, but the chorus was just a total mess, you had to throw the whole thing in the trash. Inpainting saves you from that heartbreak. You just fix the chorus and keep that perfect verse. It is an absolute game changer for iterative production. Moving on to section 3, the art of prompting. This is all about speaking the language of your AI composers. Let's address the single biggest mistake creators make right out of the gate, using the exact same prompts for both platforms. A weak prompt is something generic like happy rock song. It gives the AI almost nothing to work with, and you're going to end up with generic, boring audio. A strong prompt, however, provides specific instruments, tempo, and mood. Think along the lines of upbeat indie rock, jingly electric guitars, driving drums, 120 BPM, major key, early 2000s influence. See the difference? That is the secret sauce for extracting professional results from your AI department. You have to tell them exactly what you want to hear. And applying these different philosophies directly to your prompts changes absolutely everything. If you want the exact same cinematic 80s vibe, you have to speak differently to each tool. For Suno, you want to use comma-separated tags like dark synthwave, minor key, 120 BPM, 80s production. But for Udio, you'd use a descriptive sentence, something like an atmospheric dark synthesizer track with a cold tension of an 80s sci-fi film. It's simple, really. Suno wants the specs, but Udio wants the scene. But hey, remember, your music department also handles sound design. Suno actually has a dedicated sounds mode. So instead of generating full songs with verses and choruses, you can flip this on to generate specific audio assets. You can ask for one-shots to get cinematic hits, impacts, and transitions. Or you can ask for loops to generate ambient environmental backgrounds, like a bustling coffee shop or a rainy forest. It literally turns Suno into a full-scale Foley and atmosphere studio.
All right, section 4, extracting stems and MIDI. This is where we take your raw assets straight into the editing room.
This step is where you grab ultimate creative control. First up, a quick definition. Stems are the individual, separated audio tracks derived from a single mix. So instead of getting just one flat MP3 file, you get the isolated vocals, the drums, the bass, and the synths all on their own separate files. The paid tiers on both platforms actually let you download these stems, which is absolutely essential if you want to bring these tracks into your own DAW for deep mixing, editing, and layering. Now, if you're downloading stems from Suno, there is a golden rule you absolutely must follow. Always use the Wave Tempo Locked Export option. See, AI-generated stems naturally have a tendency to drift around in tempo just a tiny bit. If you just download the standard audio and drop it into your DAW, it will not snap perfectly to your project's grid, and I promise you, it will drive you completely crazy trying to align it. The Tempo Locked feature fixes this before you even download it. It is a massive headache saver. But what if you just want the AI's musical ideas and not its actual audio? Well, you can actually download the underlying MIDI data directly from the Suno Stems panel. Once you've downloaded it, import it into your DAW, and make sure to accept the tempo sync prompts. Your project perfectly matches the AI's tempo. Next, map that raw note data to your own high-quality professional instrument samples. And here's a pro tip for you. Quantize your bass and synths so they're perfectly tight to the grid, but leave elements like the hi-hats unquantized. That retains the AI's natural human-sounding swing and groove. So here's a massive production problem for you. How do you film a 14th century monastery without a time machine? I mean, think about it. You've got this brilliant script about a monk in a scriptorium, or maybe a huge Roman Senate debate, but you can't just grab a regular camera crew and hop on a flight to ancient Rome, right? Usually, you'd need elaborate sets, hundreds of period-accurate costumes, and a Hollywood-sized budget. For decades, if you wanted to tell these kinds of visual stories, you were essentially locked out by the sheer cost of physical production. Okay, let's map out our masterclass for today. First, we'll look at the historic production problem, then setting up your personal VFX house, directing the AI camera, and mastering motion and keyframes. After that, we'll tackle the historical continuity challenge, and finally, cutting the final scene. Starting off with Section 1, the historic production problem, where thankfully no time machine is required. Making historical content has honestly always been an uphill battle. Until recently, your options were pretty much static textbook images, super expensive archival footage, if it even existed, or dropping a fortune on live-action reenactments. And this brilliantly illustrates the staggering difference in resources required today. A traditional reenactment, that could easily take 2 to 4 weeks, cost thousands of dollars, and require a huge crew for lighting, wardrobe, directing, you name it. But with generative AI, you get instant delivery in about 5 minutes. The cost drops to roughly $50 for a standard batch. And the crew? Well, grab a mirror because it's literally just you. AI is completely democratizing how we produce historical media. Moving on to Section 2, your personal VFX house. Let's meet Luma Dream Machine. So Luma Dream Machine, and specifically its Ray 3.14 model, is about to become your ultimate personal VFX house. If you need cinematic shots of lost eras or places where you physically just cannot film, this is the tool. And it all starts with the number 5. Lock this in your mind, 5 seconds. Luma generates these incredibly realistic 5-second cinematic clips entirely from text. These bursts of motion are the foundational building blocks we're going to use to build out our historical scenes. Now, what really sets Ray 3.1 apart is the sheer quality of those 5 seconds. We're talking native 1080p resolution right out of the gate. Plus, it supports HDR output, which is absolutely crucial for dramatic historical lighting. Imagine the warm, flickering glow of a candlelit monastery, or the harsh dynamic range of a sunset over a dusty battlefield. It gives you physically accurate lighting and fluid camera movement. This isn't just basic, jittery AI. It genuinely feels like actual film. Which brings us to Section 3, directing the AI camera. It's time to prompt like a pro. If you want professional results, you've got to stop acting like a software user and start acting like a film director blocking a scene. Let's compare a beginner prompt like cool futuristic city at night to a real director's prompt. A wide aerial shot of a neon-lit city skyline at midnight, cars passing below, camera slowly pushing forward. See the difference? That first one is just a vague vibe. You're leaving all the compositional choices to the AI. And honestly, you'll probably just get something generic. The second one, it defines the shot type, the lighting, the secondary motion of the cars, and the exact camera movement. You're translating cinematic logic into visual reality. Now, Luma does have some unique quirks you need to know about. For the best results, do use mid-action verbs, like running instead of begins to run. Also, definitely include secondary consequences. So if a horse is galloping, describe the dust getting kicked up or the wind blowing in the rider's hair. You also want to describe temporal movement, what happens as the scene actually progresses. But here's what you absolutely must avoid. Don't use negative prompts and stay away from aesthetic buzzwords like vibrant or whimsical. And get this, avoid hyperrealistic. Ray 3.14 is a positive-only model, and ironically, throwing in terms like hyperrealistic can actually degrade the output and make it look totally artificial. Crazy, right? All right, Section 4, mastering motion and keyframes to really bridge that gap. So how do you take a single static moment and turn it into dynamic storytelling? How do we extend the action? Well, Luma has this brilliant extend feature. You can use image keyframes to seamlessly transition from one visual target to another. It's like a giant puzzle coming together. First, you just start with your base video, usually that initial generation. Next, you tap the extend feature. Third, you add a brand new image keyframe as your final destination. And finally, you generate. Luma's engine actually figures out all the cinematic physics required to smoothly transition from your starting video straight to that destination image you uploaded. But hey, a quick word of caution from the pros here. When you're combining keyframes and text prompts, only describe what actually changes during that transition. Think about it. If you're transitioning a shot of a medieval castle from a sunset to a starry night, just prompt the lighting change and the stars appearing. Do not re-describe the stone walls or the moat. If you mention those static elements again, the AI might try to regenerate them, and suddenly your solid stone castle starts morphing and melting mid-shot. Definitely not the vibe we're going for. On to Section 5, the historical continuity challenge. Let's talk about preventing visual drift. The absolute biggest pitfall with generating historical scenes is what we call era leakage. You know, when a World War I trench coat suddenly morphs into a modern winter jacket, or a 19th century peasant suddenly has perfect modern-day posture. So the crucial point is this quote from professional AI creators. If a viewer notices the AI before they notice the history, the workflow failed. Your number one job is to protect the continuity of the world you're building, because if the architecture randomly shifts styles between shots, you've instantly pulled the viewer right out of the story. So how do we fix this? The solution is a really vital technique called the reference image first workflow. Instead of just typing a text prompt and crossing your fingers that the AI keeps your general looking the same on the battlefield, you start by sourcing or creating a high-fidelity still image of your exact subject or setting. Then you use that image as the first frame input for your video generation. You are essentially anchoring the visual identity before any motion is ever generated. Now, you don't need to anchor every single thing, but you absolutely must lock in the elements that the audience will spot if they change. Anchor signature clothing, things like an officer's coat or a ceremonial dress. Anchor fixed locations that show up a lot, like a palace hall or a trench. You've got to anchor recurring faces if a character is in multiple clips. And for sure, anchor hero objects. If your whole scene revolves around signing a famous historical letter, that letter better look exactly the same from shot to shot.
All right, welcome to this explainer. If you've ever wanted to craft those 100% human-sounding AI voices for your long-form deep dives, well, you are definitely in the right place. Today, we're exploring exactly how ElevenLabs became the absolute gold standard for digital voice actors. We're talking about generating commanding, professional narrators that don't just read text, but actually captivate an audience.
Just take a look at this exact prompt. This was used to cast a military commander voice. Notice how you aren't just typing words here. You're literally directing an actor. By asking for a deep, resonant baritone with authoritative precision, the AI instantly understands the exact gravitas and projection you need to get that loud, commanding narrator. It's pretty wild.
And honestly, that level of precision has driven some massive scale. ElevenLabs recently hit a staggering $11 billion valuation after a $500 million Series D funding round. Think about that for a second. That number tells us that high-fidelity, emotion-first AI audio isn't just some passing gimmick. It's quickly becoming a foundational piece of the global digital infrastructure, and it's clearly capturing the attention of major investors. So to really understand how to harness this power, here's our agenda for today. We'll cover 1. The gold standard AI voice. 2. Directing the AI actor. 3. The secret settings formula. 4. The true cost of quality. And finally, 5. Ethics, safety, and humans. Let's dive right into Section 1, the gold standard AI voice, pushing beyond robotic text-to-speech.
Check out this wild trajectory. They were founded in 2022 as a human-like text-to-speech model, but they didn't just try to be the cheapest or the fastest tool on the market. By January 2024, they raised $80 million, and by May 2026, they had crossed $500 million in annual recurring revenue, securing that Series D funding. And they did this by prioritizing audio-native emotional fidelity over commodity efficiency. Basically, they focused on the actual soul of the voice.
And that focus on the soul of the voice really culminated in their V3 Alpha model, because it isn't just reading your script, it is actively performing it. It scored an exceptional 9.4 out of 10 for naturalness, it supports over 70 languages, handles multi-speaker dialogue natively, and literally understands the emotional range required to shift tone seamlessly. It's a total game changer for those incredibly natural conversations or solo narrations.
Okay, moving to Section 2, directing the AI actor, using stage directions for synthesized speech. Now this is where we leap from robotic reading to true acting. They introduced audio tags, which are essentially inline directives that you write right into your script using square brackets. Want your narrator to suddenly drop to a whisper? Just type bracket whispers bracket. It gives you this unprecedented level of control, letting you trigger nonverbal sounds and dramatic tone shifts instantly. It's exactly like handing stage directions to a real human voice actor in a booth.
Let's look at how this works in practice. You literally just type your stage direction right into the text. Like, I can't believe it. This is amazing. Now, the V3 model doesn't just awkwardly say the word laughs out loud. Instead, it seamlessly weaves a real, human-sounding laugh right into the prosody, the natural rhythm and melody of the sentence. The emotion feels incredibly authentic.
And this tech also extends to your own voice through cloning. Let's say you want to be the commanding voice of your own content, but you really don't want to sit in a recording booth all day. You can create a highly usable, multilingual replica of yourself in just a few clicks. Upload a short sample for instant cloning, or up to 3 hours for high-fidelity professional cloning. Verify your identity, and suddenly, boom, your voice is speaking fluently across 32 different languages. All right, Section 3, the secret settings formula, unlocking 100% human deliveries.
So here's a somewhat counterintuitive truth about AI voice generation. The defaults usually aren't tuned for realism. They're actually tuned for highly stable, monotonous corporate narration. Think of automated phone menus or boring e-learning modules. They are designed to be perfectly consistent. But if you're making engaging viral content or a deep dive, consistency equals robotic. Real human speech naturally has tons of micro variations in speed, pitch, and emotion.
So, the settings in this table? This is your absolute goldmine for 100% human-sounding audio. Look at the stability setting. The default is 50%, but the pro secret is to actually turn stability down to the 30 to 40% range. Then you want to push similarity boost up to around 75 or 80%, add a touch of style exaggeration at 15 to 25%, turn speaker boost on for solo narrations, and adjust the speed to perfectly match your natural spoken cadence.
It feels backwards, right? But pushing that stability up is exactly what ruins the output. High stability strips away all those tiny pitch and timing variations that humans use naturally. By intentionally lowering the stability to 30 or 40%, you are forcing the AI to introduce natural emotional arcs and expressive fluctuations. The AI literally needs this variance to sound human and truly authoritative.
Oh, and here's another pro tip. Use the pause syntax. Don't just rely on commas and periods to pace your script. By explicitly typing out tags like bracket pause 0.5s bracket, you gain this surgical control over the rhythm of your commanding voice. It is absolutely perfect for setting up punchlines or holding for a dramatic reveal in your long-form deep dives, making the entire delivery sound so intentional.
Let's look at Section 4, the true cost of quality, the brutal truth about credits. So, while the output quality is unmatched, there is a brutal truth we have to talk about regarding the credit system. You are going to burn through your paid credits fast. Why? Because you are charged for every single character generated, even if the AI glitches, randomly shifts volume, or puts in a weird pause. Getting that 100% perfect commanding human read often means regenerating the exact same sentence multiple times, and yep, every single attempt drains your wallet. When you objectively stack ElevenLabs up against its competitors, you really see the trade-off. Budget tools like Murph or Amazon Poly are super friendly on the wallet, but they're largely robotic. Lavo and Play.h sit right in the mid-range. But ElevenLabs, they sit at the premium tier. They're consciously trading cheap commodity efficiency for high-end, emotional intelligence. You're definitely paying a premium, but you're getting a genuine AI actor in return.
Today, we're diving into an incredible, completely free, open-source image enhancer called Upscale. We're going to see exactly how this tool magically transforms your lowest resolution historical photos and faded memories into crystal-clear 4K masterpieces, all without losing a shred of detail.
You know that core problem we all face? You probably have a shoebox or frankly just a super messy digital hard drive stuffed with old pixelated point-and-shoot camera photos from the 90s or early 2000s. They capture absolutely priceless memories, but let's be honest, they look terrible on modern high-resolution screens. So here's our roadmap for today. 1. The blurry photo problem. 2. Enter Upscale, free and offline. 3. Under the hood. 4. Choosing the right model. 5. Hardware needs and limits. And finally, 6. Restoring your memories today.
Section 1. The blurry photo problem. Fading memories.
For a long time, the universal frustration of trying to digitize and enlarge our older family photos just resulted in a blurry, blocky mess. And yeah, cloud tools and premium software have existed to fix this for a while, but they come with some major catches. Cloud services like Bring Back might charge you per photo, while dedicated premium software like Topaz Gigapixel AI can run you a hefty $149 a year in subscription fees. But more importantly, many of these services force you to upload your deeply private family memories to unknown servers. Well, the local open source approach flips this entirely on its head.
Section 2. Enter Upscale, free and offline, the $0 superpower.
This brings us to a massive game changer in the open source community. Created by developers Nayam Amarshi and TGS963, Upscale was actually built with a Linux-first philosophy before expanding to Mac and Windows. It gives you studio-grade AI upscaling entirely for free. We're talking 100% offline, absolutely zero subscriptions, and no watermarks whatsoever. And because it runs entirely locally, your sensitive photos never ever leave your hard drive.
Section 3. Under the hood, the AI engine working its magic.
So how does this actually work without simply stretching the pixels out like older legacy software used to do? The answer is RealSRGAN. Think of RealSRGAN as the powerful V8 engine sitting right under the hood of Upscale. Instead of just blowing a photo up, this AI framework was trained on massive amounts of synthetic data, so it understands what real-world degradation actually looks like. It smartly hallucinates plausible details to fill in the blurry gaps. It's literally reconstructing fine textures, sharp edges, and clear lines that simply didn't exist in your original file.
Section 4. Choosing the right model, your masterclass. Now, here is where we separate the novices from the pros. Upscale isn't just a basic one-click magic wand. Choosing the wrong AI model can actually ruin an image with weird artifacts, so you really need to match the engine to your specific image. Think of this slide as your ultimate cheat sheet. If you're reviving an old portrait or dealing with blurry text, Remacry is incredibly effective at preserving natural background blur while sharpening facial features. For realistic photography and historical architecture, high fidelity is your go-to. If you're a gamer upscaling retro video game screenshots, light is insanely fast and super effective. And for anime or digital illustrations, the digital art model smooths outlines and keeps all those colors perfectly vibrant. And oh man, if you have an incredibly tiny image, you have a secret weapon, the double upscale trick. In the testing data, there was an impossibly small 216 by 144 pixel image of a pocket watch that just looked like random blocks of color. But by checking the double upscale box and using that Remacry model, the software ran the AI process twice. It successfully restored the Roman numerals and the watch edges to a completely recognizable state. That is the sheer power of this tool when you configure it correctly.
Section 5. Hardware needs and limits. Managing expectations. To make sure you aren't disappointed, we do need to acknowledge that Upscale is doing some seriously heavy computational lifting here. Because it processes locally using the NCN Vulkan backend, your computer's graphics card is doing all the heavy lifting. Having a dedicated GPU like a modern NVIDIA or AMD card is highly recommended. With a dedicated card, a standard photo upscales in a blazing fast 10 to 30 seconds. Now, if you're running on basic integrated graphics, it'll still work, but you should expect much slower processing times, especially if you decide to batch process an entire folder of images at once.
It's also totally vital to understand the limitations. AI is powerful, for sure, but it can't invent reality out of thin air. Upscale cannot fix severe motion blur. It can't de-blur an image that is completely out of focus. And it definitely cannot magically create true detail out of pure camera noise. It enhances what is already there. It doesn't perform miracles on completely destroyed data.
Today, we're breaking down the tool powering this whole movement, the Viggle AI revolution. We're going to look at its journey from simple, goofy memes all the way up to the ongoing debates it's sparking in professional motion capture. Right? Like seriously, how on earth is the Mona Lisa doing the latest TikTok dance? We're seeing classical art, super stiff corporate headshots, and even historical figures suddenly executing flawless viral choreography. And it looks almost too good to be some cheap, glitchy filter, doesn't it? Well, that's because it's not just a simple face swap. There's some seriously deep technology at play here that allows these completely static images to come to life with incredible physical coherence.
So here is our roadmap for today's explainer. 1. The viral dance craze. 2. How motion transfer works. 3. Making your character move.
4. The secret to viral memes. 5. Viggle versus motion capture. And 6. Is Viggle AI worth it?
Okay, let's dive into this with section 1, the viral dance craze.
5 million. Wrap your head around that number for a second. That is the massive user base Viggle AI amassed incredibly quickly. What started out just as a simple bot operating within a Discord server totally exploded into this huge community of over 5 million creators. And these are people who are just hungry for fresh, engaging social media content. It operates a lot like Midjourney did in its early days, right inside Discord, which, yeah, might seem a bit chaotic at first, but it proved to be the absolute perfect breeding ground for viral, user-generated experimentation. The idea literally spread like wildfire.
Moving right along to section 2, how motion transfer works. So to really get Viggle, you have to understand this concept called motion transfer. Basically, this is the process of taking a static character photo and merging it with a motion video template. The AI maps that movement directly onto the character's geometry. Now, this is drastically different from what tools like Runway or Pika do. Those tools are amazing, don't get me wrong, but they do text-to-video where you type a prompt and they hallucinate a brand new, dreamy scene from scratch. Viggle, on the other hand, deconstructs complex movements from a source video, like, say, a real person dancing, and intelligently applies those exact movements to the specific limbs and torso of your static image. The brain pulling the strings behind this magic is the JST1 Foundation model. I like to think of this model as the ultimate digital puppet master, and honestly, it brilliantly illustrates just how far AI has come. The JST1 model actually has a deep physics-based understanding of 3D space. It actually knows the difference between an arm, a leg, and a torso. So instead of just blindly warping pixels around and hoping for the best, it understands physical joints and how they should behave in reality. That's exactly why the characters don't look like stiff, wobbly robots. They move naturally.
Which brings us to section 3, making your character move. You might be wondering how hard this is to do. Well, the actual workflow inside Discord is surprisingly simple. You jump into one of the creation channels and just follow a few steps. Step 1, upload your character image. Let's say you want to take a cool 3D model of Paul Atreides from Dune. You need a clear, high-resolution, front-facing photo of him. If the face is turned to the side or hidden in dark shadows, the AI is going to struggle. Step 2, upload a reference motion video. A clean, 5-second clip of a single person dancing in a well-lit room works best here. And step 3, just hit generate using the /animate command. The AI analyzes the motion, maps it seamlessly to Paul Atreides, and boom, suddenly the Lozano guy is performing the latest TikTok dance trend. But wait, you can actually level up your creative options even more with the /mix command. This feature allows you to not only animate the character, but blend them seamlessly into a custom background scene. It's so cool. You upload your character, you upload a background image, maybe it's a massive concert stage or a sunny beach, and you upload your motion video. Viggle composites all 3 of those elements together for you. It's an incredibly powerful way to place these digital puppets into very specific storytelling environments. Now for the fun stuff. Section 4, the secret to viral memes.
The secret ingredient here, guys, is contrast. As the sources point out, the uncanny valley is actually your friend in this context. Seeing an inanimate object perfectly perform a popular dance is exactly what makes people hit that share button. We as humans are naturally unsettled, yet highly entertained by things that are almost human but not quite. So when you take the statue of David, or a super stoic historical portrait, or even just your company's logo, and make it flawlessly execute a fast-paced pop choreography routine, it triggers this instinctual humor. It is the sheer absurdity of the visual that makes you stop scrolling. Now, pay attention to this part, because here is a crucial pitfall a lot of beginners fall into. Viggle videos are generated completely silent. Yep, no sound. But a viral video's anatomy is 50% visual animation and 50% trending audio. Your perfectly dancing Mona Lisa won't go anywhere on social media if she's dancing in dead silence. You absolutely must take that generated video file into an external editor, something like CapCut or directly into Instagram Reels, to sync it up with a trending sound effect or song. That perfect pairing, that's where the viral magic actually happens. Let's zoom out a bit for section 5, Viggle versus motion capture. So the crucial point in the wider industry debate is understanding what these tools actually produce. Generative AI, like Viggle, gives you a baked 2D video. Traditional 3D mocap, like the professional suits from Rococo, gives you true 3D data. AI uses a monocular, fixed camera perspective based strictly on the video you uploaded. Mocap, though, allows for multi-angle, totally dynamic camera setups in a 3D engine. And what about editing? Well, if you want to change the AI motion, you pretty much have to regenerate the whole thing from scratch. With mocap, the skeletal data is fully non-destructive and endlessly editable. To put it plainly, Viggle locks you to a single 2D camera view. It doesn't produce editable skeletal animation or joint rotations. What does this mean? It means that while Viggle is an absolute powerhouse for making memes, short-form social content, and quick visual experiments, it's not about to replace professional studio pipelines. Game developers, interactive content creators, and VFX artists still require true, editable, reusable 3D data that can be relit and viewed from literally any angle. The experts all agree on this. AI isn't replacing mocap right now. It's just a brand new tool serving a totally different creative intent.